We're here for the multi-substrate dry digester technology tour today. Okay, so a warm welcome to everyone. It's my pleasure to host you today to introduce you to EcoYou, what we stand for, what has been built, and how we're redefining sustainability. On the screen in front of you, you can see our vision and mission. EcoYou is built on a simple yet powerful idea that sustainability does not need to compromise innovation, beauty, or affordability. For over 30 years, we have been converting agrofibers, agricultural waste into high quality materials. In doing so, we have processed millions of tons of agrofibers into building materials. We've generated billions of rupees in additional income for farmers and for rural economies. And we've saved millions of tons of carbon dioxide emissions and preserved millions of trees that would otherwise have been cut. These numbers are not just statistics. Each one represents lives uplifted, forests preserved, and a healthier planet. What drives us? Innovation, high functionality, affordability, sustainability, honesty, adaptability. These are some of our core values as a company. They're not just words. These are how we make decisions here at EcoYou. In R&D, in choosing raw materials, in pricing, in how we design our products, how we design for every single vertical. With these values, we serve many sectors: living spaces, commercial spaces, healthcare, hospitality, government projects, education, retail, logistics, and of course, the industries. Sugar industry is a big one that we serve. More on that by Praveen. So now I would just like to take you through our three different verticals as a company. So now I would just like to take you through our three different verticals as a company. One of our verticals, life, is essentially all about enhancing daily life. It is more holistic. It includes efforts beyond just construction or energy. This is about designing healthier living environments. Under this vertical, we design products that are, of course, made from agro waste and recycled materials, but they're products that have an impact in daily life and in supporting sustainable behaviors. So through the life vertical, we aim to embed sustainability into our homes, into our workplaces, and even our habits, so that EcoYou isn't just what we build, but it is actually how we live. Some of our landmark projects in this space have been the world's second best building by IIT Bombay Team Shunya. This was a 100% eco-friendly building. The world's best hospital using agro boards. The hospital was by Infosys. And we've also partnered with a furniture brand to make the world's first BIS approved agro board. Well, where the world's first BIS approved agro board, which was our board, was actually used to make furniture. So these are some examples of this vertical. Next, I'll talk about the build vertical, which essentially is all about revolutionizing construction, sustainable, affordable, and durable building materials from agrofibers. Our eco-friendly construction vertical has composite boards and panels engineered to substitute traditional wood, cement, gypsum, any other carbon-intensive materials, loads of carbon-intensive materials. So for example, our EcoBoard is used in products like EcoRack, which is storage solutions, EcoCraft, which is blocks made for creative and design purposes. And all of these products are strong, durable, and designed with the environment in mind. Some projects to shine a light on are the world's largest warehouse, which we did for Reliance, the world's best modular construction, which we did for a brand called Loomcraft, and the world's best office, which is Puma. I'd like to invite you to visit our website post this call, where you can find details should you be interested in looking at case studies on any of these projects. We have very detailed case studies on the website that you can have a look at. And finally, the energy vertical, which is the primary reason that you all are here. This vertical of ours is all about powering a brighter world. It's all about clean energy solutions from waste resources, heat, electricity, biofuel, biomanure, biohydrogen. We dream of this vertical having all this and more. We have 35 years of experience in this space. There are 250 plus digesters that have already been installed and more, more that we are working on. In fact, the company started 30 years ago with this particular product. And I will let Praveen now take us through more on the energy vertical, as well as a little history on how the company started as well. So over to you, Praveen.
Thank you very much, Rashi. So we'll just get into this just in 2 minutes. I'll just quickly wrap up the thing and we'll go to the dry digester comparison. So we are almost, the journey is strong. So we are very happy to have Mario Cavajal from Sulzer today with us. So he was one of the main key person to introduce ESTR digesters in India, wet digesters. And of course, our journey has began and we have done the first power generation from biogas in Pakistan with General Electric motors engines in 99. Further, India's first CBG plant in 2010 was also done by us along with Green Elephant, so 10 TPD plant with spent wash. So it's the world's first successful installation globally. So then we went into pharma, dairy, and other places. Finally, in 2024 is the dry digester, which why we all have come here. And also, we would like to mention that the IoT monitoring system for both dry and wet digesters have been introduced, where all the 30 years of expertise of EcoYou has been brought there with artificial intelligence is also part of the best product we are able to offer to all our customers. So we are very proud to have a presence globally. So we have pretty much covered most of the globe in this case. So we strongly believe in collaborations of genuine collaboration. So definitely internationally Rückert NatUrgas, which will have a little bit more detailing today. Sulzer was also there. Also, we are also working, also have a license with BARC and higher engineering technology of ISC Professor Rajan. So we are also working with Indian Oil to do more detailing of the technologies for CBG. So basically the biodigesters, the biodigesters pretty much decomposition, biogas production, fertilizer, and no accumulation is a common for both the digesters, maybe wet or dry. So these play both fundamentally the same role. So now we'll go to the next slide where we'll be seeing the pretty much a wet digester, which is pretty much very prominent in the sugar industry. So there are many installations everywhere. So where typically the design is designed for 8 to 12% total solids. In the next slide, we'll be seeing the dry digester, which is pretty much designed for almost 25 tons total solids in feed. So I'll just give the comparison, then Rückert will take through the dry digester. So I think it creates a value of what both define. So what's the difference between both? So which is better, which is where it is better, where the other thing is better. So we'll just go through a few slides and then Rückert will join. So if you take a basic 9 TPD wet digester plant requirement, so these are the requirement like an average wet digester requires when we are using solids like press mud or Napier. So it will require at least 30 tons of fresh water, which requires to dilute this thing, and there are these slurry tanks for each digester which is considered, and total volume of 20 average 7,000 meter cube into 3 is almost 23,000 meter cube. So typically this is how a wet digester looks set up. So let's see in the next slide what happens. So pretty much it is very clean. There is no requirement of water. So there is no requirement of slurry tanks. Now it's just pure 2 digesters that do just half of the volume, approximately less than half, which is required for a dry digester. So typically, if you say, so we have made a comparison of both the things. So if for a 910 TPD, you still require a 220 tons approximately of feed. And the main difference you see is the target slurry And also the recirculation volume is very high. In wet technology, where almost 264 tons is required to recirculation, and that's where more is required. Also, the fresh water of 66 tons is required in wet digester. So that's one thing which is very highly required. You will be able to see where the digester volume is just 6,000 in dry digester, whereas 15,000 in wet digester. That is due to you're adding more and more water to just dilute the digestate and making it usable. So, but many people say that there's a difference of the CPG's generation is same in both. So when you efficiently work with any digester, you go to get the same CPG. Only the water consumption is less. So now there are pros and cons. Of course, dry digester you have less water, no slurry tanks required. So a lot of advantages here. However, it can be used only for substrates having high solids. However, if the solids is very low, then for example, it may be dairy effluent, or it may be spent wash, or it may be pharma effluents which are 8 to 12%, which requires a wet digester. So they cannot be used in dry digester. So when to use dry digester, when to use wet digester? Of course, the answer is simple. When the solids are high, more than 20-25%, like press mud, poultry litter, Napier gas, it is very well suited for them. However, in wet digester is more suited for spent wash or any diluted. If you want to dilute and use it, then it can be used. But again, the disadvantage of extra water is there. So before I hand over to Claus, we just want to inform, we have already informed that the IoT system or AI based is for both wet and dry has been introduced. So this is the first time we are launching this in front of our audience. So next, I hand over it to Rückert. So he will be taking us through the dry digester component. So most of the elements in the existing plant, which our team is there to show you, have been captured, and Rückert will talk over it, and then Himanshi will show one by one item at a time. So, Claus, before handing over to Claus, Claus is the inventor of this technology, Rückert NatUrgas. He has the European patents for it, and he has done almost 90 projects across the globe with different substrates. So in this project, which we are be seeing is using corn maize, and also they are using the old grass and other substrates, which our team will also be showing it. So Claus, I think you can start off.
Yeah, very warm welcome from my side to everybody. I'm happy to be able to present you some details about our design from biogas for biogas plants, and hopefully you get the difference between wet and dry digester. It's a very old plant we did not 20 years ago, but almost 20 years ago. It's in the northern part of Germany, and you can see the footprint of site. The rectangular digester you can see in the middle of the footprint is about 27 meters long and 50 meters in width. And the net volume is about 2,000 cubic meters. And this plant was actually designed for 600 kilowatt electrical performance. And later on, post digester has been built. So we have 2,000 cubic meter post digester on site. So in total, it's 4,000 cubic meters. And it's possible to generate more than, oh, it's too quick, more than 500 to 600 cubic meters of biogas per hour with this dry digester. As you can see on the right side, there you can see a screw conveyor, and all the substrate we have as a feedstock is brought into the digester in a dry like it is as a dry matter. So stones, metal parts, big wooden parts are not welcome. They block a pump or the screw. So with this digester, we are able to feed the feedstock dry like it is with 20, 30, 40% of dry matter content. And I can give you a small idea why we can do this. It is because of the agitators. We built the digester around the agitators, And as long as they are running, we can homogenize and mix the substrate all together. So we push up sediments and we push down floating parts. And so we mix everything to the sludge inside the digester. Pictures there, you can see where the feedstock is brought in a drive-in silo. So this what you can see is maize silage. It's, I think, my guess it's quite close to Napier grass. And we seal it to avoid oxygen, because we need to store it all over 1 year, because in Germany we have only one season. It's starting now, where maize can be harvested, and then we need to store it for almost 1 year. On this special biogas plant, we have almost 60% of the feedstock is grass, means it's from extensive agriculture fields. It's harvested several times a year, and it's chopped to very small pieces and stored in a silo as well. Here you can see the front end loader filling in the substrate, dry like it is, to a screw conveyor. And this is very easy to handle. And this is a background why we can run the digester on almost 16% of dry matter content at the end of the digester, means after the bacteria did their work. So we take out the biogas, we take out the carbon, so the dry matter content lowers. And at the end of the digester, we are around 16% dry matter content. This you can only get if you feed dry. If you feed it wet, the pump is limited to 12, might be 14% in the inlet. So it means in the incoming fraction to the incoming substrate to the digester, the bacteria do their work, and outcoming you're only between 6, might be 8%. So you will never get more than 8 or 10% of dry matter content if you feed wet. That's why we save volume. It's not because the bacteria are different. It's not because the working condition for bacteria are different. We do the same job, but we are able to homogenize the content of the digester. After the digester, we have the dewatering. We do it directly after the digester, because if the dry matter content increases inside the digester, we give back the liquids after dewatering directly to the digester. So bacteria are still alive, it's still warm, it's still active, and we only take out used substrate. We take it out of the process and store it beside the digester, or we can truck it back to the silo until the time is come to use it as a fertilizer. Here you can see an open lagoon. It's a rectangle, no, it's a tank, not a rectangle, it's a round tank without a cover. In the back you can see a new, it's built last year. It's a 3,000 cubic meter tank to store the liquid fraction after digester. It's a different view. What we do on site, we use the biogas directly to produce electricity and heat. And on this site, we have in total 1,200 kilowatt installed performance for CHP. One CHP is on site. You can see 1,259 kilowatt performance.
So can you convert into raw biogas by any chance, Rückert?
It's around 550 to 600 cubic meters. I'm just looking where it's a flow meter for the gas, but it's a proof. If engine is running, it only can run on gas. It's 100% running on biogas. So you can see one engine is 716, the other is 543. Gas holder is still full, so because it's totally yellow. So about the feedstock, I already told you. Digester volume total 4,000 cubic meters, and raw biogas is almost 600 cubic meters, or 580 calculated. And this is plenty of power. There is the So I'm doing biogas more than 30 years now, and there's a misunderstanding about the digester. The digester is completely filled. It's a static process. You feed it every hour, you take out substrate every hour, you keep the temperature very close to 45, 47. Most important is you keep it where it is, and bacteria are doing their work 24/7 for you. And the most important thing is that the digester is homogenized, mixed up and homogenized. If you can't make sure that you can do that all over the years, it's not running, you have problems. And if you have problems in a digester, you will not produce gas. And producing gas is the most important thing. So feed them, heat them, and you will get the gas. You don't need to know how it works, but believe me, I didn't knew before, and it worked. I was the luckiest man on world, like burning the first biogas. And we learned about the years how to build a digester, and a digester is good if it has a pump and if it has a mixer. That works.
Thank you, Klaus. Now we will move to the part where we go to the live technology tour. Hi, Himanshi. Everyone, we've got Himanshi from our team who is currently live at the facility. And she's going to take us through the facility along with Klaus Rückert, who is going to also take us through the facility and talk to us about it where necessary. Himanshi, if you can just slowly walk and show everyone present here the facility.
I'm just gonna walk around and show you, and maybe Klaus, if you have, if you want to support the video with your explanations, which you already did, might be helpful to give everyone a clearer perspective.
Yes, we can. Oh, it's unmuted.
No, we can hear you.
Okay, so we can see the drive-in silo. They're huge. It's because feedstock is around 60 to 70 tons per day, and we can yield around 150 to 220 cubic meter of biogas per ton of feedstock. It depends on dry matter content and the quality. So one of the biggest problems in Germany is the rainfall. If it rains on site, we have plenty of sealed area, and we have to catch the water. We can't let it go, and we don't need it in the biogas process. So we have to make sure that we don't pollute the environment. So here you can see the dosing feeder. In former times, we decided to build a building around the dosing feeder, so it's easier to throw in the feedstock with the front end loader. So the operator is able to have a good view inside the dosing feeder. That's why we have a cellar or some ground floor building. And you can see it looks like 20 years old. We have corrosion because of the acids in the feedstock.
They were just filling it.
I'm missing the front end loader. It's gone. It's gone. So you can see this is not.
This one is very at large because this is the main feeding system of the diet digester.
Right.
Mr. Praveen, you have told us that you are pumping the material in digester, but they are having some screw conveyor. They are showing some screw conveyor there. You are on mute. Please unmute.
So the pumping of means basically this is a little bit older version. As Rückert told, this is a 20-year-old site. So the recent versions, what they are doing is to remove the stones. We are washing it. We keep a small 50-meter cube where the overflow comes inside that thing, and then it pumps. So that's a recent advancement which is there and which we are adopting for the new projects.
Himanshu, might be you can go across that along that we can see the screw conveyor.
Yeah. Oh.
To the right, to the right, to the right. Stop, 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 stop. No, it's too far. Ah, yeah, here we go. You know it better than I do.
There's a big box in the middle.
Very nice, yeah. So on
Do
the
you
left
want
side,
me
we
to-
can, yeah, on the left side, we can see the digester. We can see the windows where we can have a look inside. I'm not sure whether it's possible now or the agitator is running now. So it's difficult because it's very bright light outside.
It might be hard, but basically it looks like a lot of mush that's being turned by metal rods, sort of.
I'm sure we can find a small video later. So at the very end, if you go a little bit further, so you can see the screw conveyor. And they feed some grain as well. You can see a small mill, grain mill. It's to push bacteria to produce more. Yep, very good. To produce more biogas. And if the price is low for grain, they buy in grain and convert it to electricity and heat. Some years ago, they used an extra external chopper on site. That's because the screw conveyor doesn't go directly to the digester. It's running in circles, but they decided to chop it while harvesting. It's quicker and it's cheaper. And the conservation in drive-in silo is easier and better from the quality. So you save gas. You don't lose gas while storage. Here you can see the external heat exchanger. We take out substrate from the digester, heat it up, and bring it back to the digester. So it's external. Inside the digester, we only have the agitators, 2 of them, and measurement for temperature and leveling. And rest is bacteria and sludge.
It smells really good here.
So the digester is 27 meters long, 6 meters high, and 15 meters in width. So net volume 2,000 cubic meters. We can build it a little bit bigger, 3,000, 3,500 in a rectangular, and 5,000 to 6,000 in a round digester. So this is a product, dry fertilizer, not really dry. It's 25 to 30% dry matter content, but it looks like a compost. It's called anaerobic compost, and you can use it as fertilizer in the fields or mix it with other kind of material and you sell it as a fertilizer.
You want me to go inside?
Please. So in Germany or Europe, we have cold temperatures in winter and not that warm in summertime. We have lots of rain in different seasons, and that's why we have a pump room. We call it pumping room, to keep system warm, avoid problems with frost. And here you can see the drives from the agitators. It's 18.5 kilowatt hours performance, and run the speed in circle is 5 UP per minute. So if you walk a little bit to the side, we can see the other agitator drive in the back, the green part. And on top we have a crane to put them out. Yeah, there's another one, and it's open. The digester is rectangular. It's open, like we've seen in the very beginning on the drawing. I'm not sure you can step down. Go down the stairs, please. Then we'll find some pumps to manage the substrate. One pump is to feed the dewatering, the separator, and the other is for the heating circle. There's a small chopper installed. If the fibers, while heating, we pump it to be heated, and if we pump it, we chop it the fibers to smaller parts, and we can able to take out more biogas. I've seen this installation on the Energy Week in India, in New Delhi. It was a company. No one was interested in this kind of equipment. I told the sellers on site, because they were a little bit sad, that people will learn that they will need it on site, this equipment. So it only takes a few years and then they will be busy. This equipment is needed if you handle with solids on site.
Should I
Just let me
take
say,
you?
please.
Somebody just asks for us to showcase the digester output input inlet to SLS, if there is such a thing possible right now.
I'm not sure about the question. Can you repeat it, please?
Showcase the digester output input inlet to SLS.
The dewatering system, the solid liquid system. Where can we find
Dewatering
that?
system, you have to go to the first floor somehow.
Okay, if it's not possible, then we can skip that.
Yeah,
I think it's possible.
it must be somewhere, because dry substrate after digester falls out on the right side. So if you go up the stairs, upstairs.
Okay, just a second. Just a second, going upstairs. But also what we could do is we could keep these questions and maybe take photos. I can document it later and also send it over so that there's clarity.
Yes, that sounds good. I just saw a very specific request regarding the site, so that's why I shared it. But yeah, do it only if it's easy enough.
Okay. We are walking up to the first floor. Hello. And we want to see the inlet SS. What was it?
The dewatering was required, I guess.
Output input inlet to SLS.
So if you go to the end, yeah, then to the right, there must. So on the right side in the red building, there's the gas holder inside.
Solid liquid separator.
Yeah, it should be. If you turn to the right now, there's a door, and inside there's a dewatering unit. On the right side, we have the over and under pressure valve for the digester.
Hello.
Here you can see the dewatering units. So it's screw press. It's a little bit tricky to install because the content from the digester is producing biogas in the digester, and it produces biogas in the pipes as well. And it produces biogas in the liquid after dewatering as well. So you have to avoid gas bubbles inside the pipes and the pumps. So you have to get rid of them. And it depends on what you are what you have as a feedstock from how much dewatering units you will need. So this is And if we build different digester, we have different dewatering units because the bacteria are all different. If you have 4 digesters, you will have 4 different population inside the digester. They split. One get Chinese, one Indian, one European. So they have different feedstock and they develop a little bit different. End product is the same. It's biogas, but the bacteria, even if you try to run them on the same temperature, they will develop in a different way. So it's very important if you do dewatering that you use the same recirculant from the dewatering unit. There's an overpressure valve. So this is not that easy to understand. On the left side, there's a gas getting out from the digester. And behind this wall, there we have a gas holder. And so the biogas is going into the gas holder. And then the right side, it's a overpressure valve for the gas holder to avoid that if pressure is getting too high, that it exhales, yes. And this piping is coming down from the pumps in the pumping room and feeds the dewatering unit. So even after decades, it's quite clear. It looks good to me. So these are external storages for biogas. It's a double membrane system because we have snow and rain. And it's the outer part, the gray part you can see is in this shape all over the year. And inside we have a second foil, and this moves up and down depending on how much biogas is stored. And in this case, we have a combination from liquid storage and gas holder. I'm not really 100% convinced of this system. I like it more if gas holder is external and tanks is extra, so it's extra system. It's more safe to run, to operate. This is a agitator. You can see on the right side, it's the blue one. Manchi, yep. This is a propeller, not submersive. It's a propeller mixer. And we use it here because it's all dewatered. There's no fibers inside. Everything we store inside this digester is dewatered before. It's very important to avoid floating parts, scum, and sediments. And here you can see the storage for liquids after dewatering. It's in use since the very beginning. Now it's September. Now they're harvesting maize and grain. And after the season, they truck all the digestate on the fields. And then it will be empty in the autumn, and over the year, over winter time, it will fill up until March, April, and then we use it again as a digestate. As a fertilizer, sorry. Yeah.
I guess that's all, right, Claude?
Yep. Yeah, we have a CHP. It's an engine, but in India, you want to produce CNG, CBG, compressed gas. So we use it for electricity. It's an engine with a generator, and it's inside. I don't know whether we need to show it.
Okay.
Himanshi,
Maybe we can.
Can you show the substrate? If you can just close up.
So this equipment is for drying, to use the heat. We get additional subsidies, additional money for the electricity if the heat is being used.
Is there anything else that I can go to?
Not yet. Biogas is not that complicated. We've seen everything: dosing feeder, digester.
Any reason why there's sawdust there? Wooden sawdust?
This is for drying. So we get it wet, And if you want to burn these wooden parts to produce heat, it's better if it's dried. So it's an area with underfloor heating, and this warm air is pressed through this wood, and then it's getting drier and drier. And if it's already dried, then we can sell it for more money per ton, and because you can use it as it's dried wood, and then you can burn it in the oven. This is actually nothing to do with biogas. It's only a possibility to use the heat from the CHP.
Okay.
Himanshi, if you can go to the substrate, the closest, I think we can close it.
The substrate, which part of it? The one that's coming out?
Not coming out. The one which is going inside. Do you have anything close by?
It's a long way to go to the beginning, yeah.
Yeah, I have to go there into the corner. Maybe you can start
Maybe
your
we
question
can-
answer.
Yes,
Rashi,
let's move on, and maybe I will just give me a
No,
moment.
you can see the torch. Where if CHP is not running, we don't want to pollute the environment with biogas, because it has a big impact on the environment. So we need to burn it. We want to burn it, but it's only for emergency case, not emergency. But if CHP is not running, we burn it.
So with the site visit ended, we're now going to move ahead into the Q&A session.
So Rückert, the question was, so we saw in this plant today, so there was a direct screw in which the fiber is directly fed into the digester. So what we are proposing recently is that we'll put an integrated tanks mixer where we can remove the stones. So in that, what we are trying to add some water, right? The overflow water is coming to the mixing tank to remove the stones and going back. So Vivek sir, question was that, okay, in this plant, there's no water or tank. So if you are putting extra tank and water, there's a dilution happening in the system, and the reason of dry digester is defeated. So can you just explain that from your side?
Yes. So we will not use water. We'll use liquids from the dewatering to mix fresh substrate with a already dewatered substrate, but with a liquid fraction. And that's only to get out stones and metal parts, because if you truck and upload the substrate, you will collect stones even if you don't want to, and in the digester or in the pumps you will find them, and this is not very helpful for the process, and that's why we have an intermediate tank.
What is the TS of the feedstock?
It's between 25 and 35%
It
dry
means
matter
we are
content.
not adding no fresh water. It is coming fresh water.
No. If we need liquids, then we will have recirculate from the dewatering unit.
So Sunil Bhateji also had some questions. So Sunil Bhateji.
Yeah, thank you, Praveen. I heard that the temperature of digestion process is around 47 or something in the digester.
So Rückert, can you just reply that the temperature?
So the connection is real bad here. Can I read it, the question in the chat, or is it you repeat it?
Asking the temperature is around 47 degrees. So is that correct?
Right. Yes.
So,
between
if you have to maintain a temperature of 47 degrees, are you taking help of the waste heat from your gas engines to raise the temperature?
So it's hardly to understand.
How a temperature of 47 degrees is maintained inside? Is it because of the exothermic reaction in the digester itself, or are you using some heating medium?
Digester is heated and the digester is insulated, and You're right. If you use lots of dry substrate, you have a self-heating in the process. In summertime, you have sun shining on the substrate as well, and you have the agitating, chopping, pumping. All this energy is in the substrate, so it's getting warmer. So it's easier to run.
Okay, so normally you are running your digestion process in thermophilic phase, that is above 35 degree.
Yeah, it makes sense to do that.
Yeah.
Right.
And my second question was, do you need a specific biomass to suit the higher solids content or the higher viscosity? Because as the viscosity of the liquid increases, then there is a danger of breakage of cell walls, biomass cell walls. So do you require a specific type of bioculture or particular enzymes additions in the process from microbiological point of view?
So microelements has nothing to do with the temperature. If you don't have the microelements, you need to add them. It only depends on the substrate. If you have cow dung or poultry manure as a side substrate, it's not necessary. If you want to run your digester only on press mud or on Napier grass, you need to add some extra microelements. But it has nothing to do with the temperature in the digester. But you're right, with viscosity, it's easier to handle the substrate if it's hotter. But that's not the main. But it's not the main reason.
That's why you are handling it at about 47 degrees, right?
We can run it on 50 or 55 as well, but it doesn't make sense. And you can't run it on 40 or 42 because of the self-heated. And in summertime, it's getting warmer, so we keep it where it is to avoid up and downs in temperature because bacteria don't like it.
Sure. And one more question about dewatering section. Do you think that, I think your outlet solids, I'm particularly talking about the press mud application, where the outlet solids percentage will be around 15%. So whether that one single stage dewatering will be sufficient to handle that solids? You have talked about screw press, but what I feel that there has to be a two-phasic solid separation device.
It depends what you want to do with the digestate.
Yeah.
So if you want to get rid of the liquid anyhow, like in a wastewater treatment plant, then you have to treat it further on. But you can use it as a liquid fertilizer, and for recirculation, it's okay if you have a one-stage dewatering. So for the process, we are fine with one stage. It depends on the treatment of the digestate later of the fertilizer. If you want to have only dry fertilizer, if you want to do this and that with the digestate or with the fertilizer, then you might be right and add some flocculant or something else. But for the process, for the biogas plant process, we don't need centrifuge, we don't need flocculant, we don't need anything.
Correct.
Ashi, I have one question. I'm Ankit from Thermix.
Hello, Ankit. Yes, please go ahead and ask.
Yeah. Good afternoon, Mr. Rückert, Mr. Klaus Rückert. Good afternoon. My question is, when we are earlier technology, wet CSTR has ample amount of water, and we limited solid content in the wet digester, so that by doing this, we are increasing the life of agitator. But in a dry digester, we drastically reduce the consumption of water. So does it mean that wet digester has a greater life of agitator and dry digester has less life of agitator?
No. The life cycle of an agitator, we have different digester. We opened after 10 years without opening in between, and agitator was still working. We had some maintenance on the bearing, and that's it. And the difference is the real agitator, so this horizontal agitator is running with 3 to 5 rounds per minute, and we don't have this high speed like on the propeller. And if you add water to the substrate, the speed is the same. So if you have paddy straw, for example, and some water around, it doesn't matter if you have 10, 15, or 5% dry matter content. This paddy straw is abrasive, and you have water around, and if the propeller is running very quick or very fast, whatever, so you have abrasion on the propeller. So it's you start like that and you end like that, and you don't have any effort of that. Instead of doing maintenance, buying propellers, but you have to open digester, you don't produce gas in this time, you have plenty of problems. So from maintenance side and operation costs, you're much cheaper with a real agitator.
Okay, sir. Okay, thank you.
Hello, sir. I have a question. Can I, please?
Yes, Saranji.
Yes, please.
Sir, we are using 12% solid. We are feeding to the digester with 12% solid. The dilution content is centrate, what we are recovering from the solid liquid separator. So, what is the difference between our system, which is having 12% solid inlet, and your system, which is having, I think, 19 to 15 to 25% solid inlet? I thought so. Both are the same. We are using. We are also using the what it called centrate or the SLS outlet. So, what is the difference between this currently using digesters and your digester, sir?
So if you feed with 12%, then you have the biodegradability from the substrate, and the outcoming substrate ends with 6 or 8%. So after digester. So, and if you use very much of this recirculate, you wash out the fibers, and retention time is getting lower. So it's a little bit tricky to do the calculation on retention time. So what we do, we have the digester, we feed, we take the gas, and we take out the digestate. And we do not have lots of recirculation, or we do not have the adding of water, even not from the storage tank later. If you have the wet digester, you have to recirculate much more of substrate. And what you do, you wash out the fibers very quick, and you're not able to take the gas. What you have high investment, you have high operation costs for maintenance of the mixers, for electricity, to manage all this stuff. And at the end of the day, you do not gain more gas. No, it's easier to operate a digester with a higher dry matter content inside.
May I ask one question, Dr. Konde here from VSI?
Yes, Dr. Konde, would be great if you can just turn your video on for us. Thank you.
So I have one question regarding particularly press mud cake, because what is happening, you are saying optimal like solid loading is the 30% when the dry digester is there. In case of press mud, you will see almost 85%, 80 to 75% moisture. So your solid loading will be around 20 to 25%. So with some dilution of water, so your optimal solid loading will be around 20%. In that case, the dry digester you are designed at 30% loading, are we using them suboptimally?
So for the dry digester, you call it dry digester. For me, it's a digester. And this digester we built or we designed, it doesn't matter. We can run it on 5% dry matter content. It's not a problem. So it will be in operation or doing the same job, even if you run it on 5% outcoming digestate or with 15 or 18. So it's the same digester, it works like it's the same, and you will have the same result. So for retention time, it's better if the dry matter content is higher because you have more energy. The organic load is higher per cubic meter. If you can manage to get your press mud on a high dry matter content, then it's okay. If you can't, so the digester is fine with this as well.
No, but if you have designed for 30% solid loading, 30% TS, in that case, volume requirement might be different in case of you have like feed with the 20% loading TS.
True.
So,
We need to know before.
yeah. So whatever the like we are showing the differences in terms of wet digester and dry digester, it may vary depending upon the feedstock characteristics. Correct.
But this is not a rocket science. So the bacteria don't mind. This is not a decision you do now. The decision you need to do is for the next decades. And if you decide for a digester with this horizontal agitators, you're free to do whatever you want the next decades. If you design your digester with like a wet digester because you think it's 15 or 20% incoming substrate and that's better, you have to live with this decision for decades because you can't change.
Okay, thank you.
Rashi, I have a question for Mario Caviezel. I hope Mario Caviezel, I hope, can you unmute or I think you can?
There I am.
So, I would like to introduce Mr. Mario Caviezel. So he is pretty much one of the founders of CSTR technology in India, for especially with collaboration with EcoBoard with Mr. V.S. Raju and himself. They have done and JRK Raju, and they have done a very fantastic job of adopting their technology for spent wash. So Mario Caviezel, my question for you is, of course, we are able to give, we are fortunate to give both wet and dry digesters from one side. But from your perspective, as a person of Solier wet digesters, so what is your recommendation for solid substrates and liquid substrate when the wet digester CSTR is good and when Rückert's dry digester is good? So can you tell from your perspective?
Okay, Klaus said it really directly and clear. With the liquid digester, how we call it, it's ever physical things we talk about. That works absolutely with lower concentrations, and you use the liquid one as you, the one I transferred to you, the whole know-how. That was the idea with a high concentrated liquid as a wash water from sugar beets or something that you have dissolved in a liquid. Then you use, of course, a liquid one. But it is true what Klaus said. You can also use the laying system called then dry digester in a liquid phase, but it makes not sense to see, because if you really want to digest a liquid, some organics dissolved in a liquid, then you use a liquid system because you have less forces on the stirrers. You have no problems with some straw or things like that can make problems on stirring systems. But in case you have any kind of solids, then you ever make the better work if you do it with a dry digester, because, or let's say only because of the system of stirring. You have these vertical stirring systems with a huge force seen on the small things we used in the liquid digesters. But you run them very slow. You may not even have to run them all the time. So you give in pulses. You only had to keep the inside moved. So it's ever one of the best system you can use. Now, can I ask you back? I transferred, let's say that way, I connect EcoBoard to Rückert technology, to Klaus, I don't know, 8, 9 years ago. How long is it? have you ever built a plant in India now? That's my question. Have you done one in the meantime?
So yeah, frankly speaking, so we have met almost 8 to 9 years back. So that time, the CBG business for solid substrate was just taking phase. Of course, the last 3 to 4 years, there was a big push with a lot of subsidies and IRADA loans in the Indian. So last 3 years, there was a big push. So definitely, we got few LOIs to do the solids digesters. So within next 3 months or 4 months, definitely you'll be able to see few plants in India.
So it seems that you, after this very long time, you are very, very close to start with the first plant. That's a great thing also for me, because I was deeply involved at that time, and I was absolutely sure that with your know-how on the liquid part, it is really time to get this technology to fill the whole area of producing biogas. Now you have the spectrum overall, and you can do whatever you want, and you need both technologies.
So the truth is, plenty of plants being built in India already with dry substrate and with a liquid substrate design, and lots of them failed. Operation cost is very high. They can't produce gas, only 10, 15% or 20% can be produced. And they have huge floating parts. They can't get rid of the scum. They can't mix it. Operation is very low. So experience is there that it doesn't work very properly. And now people are looking for better design. And now it's our time. You're right.
Okay, that sounds good, because I really heard that they had this technology, and I thought it works because Compogas, that was one of my left leg I was in during my time of active biogas business. They also tried to be in India, but they never had really a good input. They never find somewhere that really connect them to do the business. So I feel, because that's my meaning, by knowing both technologies quite well, your technology is absolutely the right one for India. That's Compogas is even the wrong one, because they have started to treat organic waste from how you call it, municipal waste, and there you have all the bad things in it, and clear they have a certain problem, and for this technology it's sure good. But if you take an organic as you have from maize or from grass that is cut to defined pieces, then you never need the Compogas system, never. So I really hope that you get forward, and it touched me personally, because I was so deeply in the whole technology involved, and also in the contacts with you two. And funny is that I just had the question if we can use the old Sulzer technology on the other side to get thicker and thicker. So you see, the one comes over, and we try to make the liquid one a bit thicker, and the thick one says we can make it also very liquid, and it still works. And in physics, it's clear and logic. The dry digester can never work on liquid, and the liquid one can never go over a certain percentage. That's physics, and you can't overrun the physics.
Well said.
Yeah, thank you very much for a nice presentation. Can we use the pressment for dry digestion?
So, Klaus, I think you were in India, you have done your analysis. So, can you just
Sure.
What are all advantages when we presently we have 10 TPD this plug flow reactor for press mud running in our one of the plant for the past 2 years. Now we are going for several digesters in our different units, and we are also tied up with Sumitomo Japan for setting up the CBG plants, as well as GAIL India also. So we have so many digesters going to come up in near future. So if we go with dry digestion of press mud, what could be the advantages or disadvantages?
So main advantages, homogenization, mixing, and you will need less volume because you can run on press mud like it is, and you don't need to add lots of external liquids. And operation of the digester is very important. Yeah. It sounds easy. So let's say it's different to explain. If you have let's say you have a digester with 4,000 cubic meters. So you have 4,000 tons of volume. If you run it on a wet digester, and if you start agitators, let's say it's off, nothing is moving inside the digester. You start agitators, and then these agitators need to push 4,000 tons to move, because you can't only do a mixing if this 4,000 cubic meters start moving. They need to move. You have to move liquids from the bottom to the top, and you have to push down. But you have to move this 4,000 tons in a circle. And this costs energy, and this is not for mixing, this is not for nothing, because it needs to move that the substrate is getting closer to the propeller of the mixers. And then it's mixed and homogenized. If you have this horizontal agitators in parallel, doesn't mind it's in a rectangular or a round tank, you have a beginning where you feed substrate, and you have an end where you take the substrate out. And if you start the mixers, and if it's only for a few minutes, you have everything mixed. And we don't have to push this 4,000 cubic meters in any direction. And if we stop mixing, it's off. So we do not lose energy to move the substrate in a circle. We only use energy to mix it. And that's the main difference. If you do understand that, if you have, let's say, both digesters and you run one, like I told you, with it parallel agitators, and you have another with the same substrate with propellers, ask people if they did both, then it can give you quite a good experience. And Himanshi is on site. These people, the owner of this site, I built them 7 plants in total with my design, and they own, I don't know, 30, 40, 50 biogas plants in Germany and in Europe. And they know the difference. They know that the parallel system is the best of them.
Sir, is it CSTR or plug flow? What kind of technology you are proposing?
So Klaus, they want to know, is this a CSTR technology or a plug flow technology?
So I don't want to be rude, but we're talking about homogenizing since more than 1 hour, 1.5 hours. It's mixed, and it's guaranteed that it's mixed. It's not plug flow, it's not this, it's not that. If agitator is running, it's mixed.
Good.
Every bacteria in this tank has the same condition. That's the important thing. We don't feed in the beginning, we feed the digester, and we feed the digester, we mix, and in every edge of this digester, and everywhere we have the same condition.
So, Pai ji, I think Saab, Atani Sugar, do you have any questions, sir?
Can you give me the word for 1 second?
Yeah,
We are
Maria.
still on mixing, Klaus, and it seems that this is one of the most important things, and the unknown that is on this technology in India, as I feel now. Well, something I really want to miss to say. If you take a liquid reactor and you have certain size of stirrers, I mean the blades of the stirrer, and you need a certain speed on it, then you will, or you can get problems at the outer part where the blade rotates. And you even can get at the point where you kill the microorganisms. And with 5 to 7 or even 10 runs per meter, UPMs, you never will have that problem that you kill some bacteria in the system. But this is really one of the things we happened. That's the reason why I know about it, that you have a too high speed or you have a too big blade, and at the outer side you have a too high energy that you really start to kill the bacteria. That's one of the things that says it is easier in case you have solids in it to take a low stirring system, very low stirring system, but big arms, big shovels that works the skin from the top down and bacteria from the top up, that it ever stays in a good in a good move, in a good consistency. That's what I say as a basic of the whole discussions we had now about slurry mixing. That was all what I want to say about.
So one idea I want to add is, if you have an operator on site who needs to run your biogas plant, you have to keep it very simple, because might be employees changes or the knowledge is easy to get. It will be difficult to find knowledge people or good educated people if you have a very simple biogas plant. Easy feeding, only agitator, make sure agitator is running, feed it, pump it out, dewater it, and gas is builds up, then it's easy to handle. It's easy to handle for the operators, and it's easy for the owner to earn money. If you have a difficult system, a different system, if you have a wet digester already and you have to push through the fibers and all this stuff, you can do that. You will find it in the world, but you need a very skilled operator. And that's a big difference, because you get very good money for your CBG, for the product, and don't save too much money on agitators or digesters, because this is what you need to produce the gas. All other equipment you can easily change, but operator is hard to find, and digester is most important thing. Like if you have an oven, the oven is most important. The heat, you can do whatever you want.
Chaitanya, I think you have some question. You raise your hand.
Thanks, Praveen. Thank you, Klaus. So firstly, when you talk about the total solid content and everything, do you test for it in your substrate that you're sending in through your screw pumps to your digester?
We do what?
Do you test for the total solid content, or how do you maintain it at an accurate level that you prefer? Because from what I understand from so far, you vary the amount of input based on the total solid content you have and how much of a gas you want as an output, right? That's your equation X, Y, Z. So if you want Y, you change the X or Z here. So I am asking, how do you maintain that? Like, do you have like operators always every day on the clock looking for this? Or because in India, the biggest problem is today I produce, let's say, an Napier grass. In winter, it can be a little more moisture content driven. In summer, it could be a little less. So my TS varies throughout the year. It's basically a wavy graph. I am trying to understand here, how do I maintain it? Or, what are the metrics that I should be looking to maintain the right efficiency?
So there are only a few things you need to do. The very first is heating or cooling. So temperature needs to be stable on the same level. Let's say this is 47 degrees. You have to make sure it's 47 degrees and it stays like that. Don't heat up. If it heats up, we cool it down. If it's too low, we heat it up. First thing. Second is feeding. Portion, let's say every hour, every 2 hours needs to be fed to the digester. Make sure if the substrate is okay, we look for the biogas. We look for the biogas quality, CH4, methane, for O2, to make sure we don't have too much oxygen inside, let's say a leakage or something like that. Look for H2S for safety reasons. And might be we look for H2, depends on the gas system, because H2 is a measurement in ppm. If it's getting higher, it's the quickest measurement to make to see that you have an overfeeding. Let's say you have products with very, very high energy and the pump doesn't stop. You can see it on the H2 very quick. It's quicker than methane falls down if you have an overload. It's quicker than pH. It's quicker than everything. It's 4 stages to produce biogas, and producing H2 is one of them.
So you look at the final metrics and figure out if the substrate that we are sending in is at the accurate measurement or not.
Right. And then we look for the volume, produced biogas volume. If this stays stable over the day, everything is okay. And about the dry matter content, we have the performance on the agitator. It's 5 meters, 6 meters diameter. And if you push it with electricity through the mud or through the digester, you have ampere. You can measure the ampere on the electric drive, and then you can see the performance. If it's getting thicker, the electrical demand is getting higher. Then we will know. If you do some analysis, you know your plant very quick. You do analyze it, it's, let's say, 24 ampere each drive. Then we know it's 12%. Let's say it's 30, you know it's 15. And let's say 35 ampere is maximum, then you will find your operation value where you can feed it. And we connect it with the dewatering unit and bring back recirculant to the digester. If it's getting too high, we do a little bit more recirculation. If it's high enough, we let it go. So we have customers that don't know even about that. I told them might be, or I told them not. They started, press button, it's running. Don't mind dry substrate or not. It's all the same. They don't even know.
So
that's important.
Basically, what Saurabh is trying to tell is that there's a VFD in the two agitators. So suddenly, if there's an increase of solids, there's an increase of amperage. So it's a feedback loop of PLC, and it automatically increases little water or it takes back. So there's a control using VFD and amperage. So how the system itself can correct sometimes, or when there's an issue by mistake if operator loads a lot of dry content.
In your experience, Cross, what could be an efficiency issue here? Like, let's just say 8-10 years down the line, what could not give me the desired 5 tons of gas that you have designed a digester for?
So if it's not,
it's
you
not
can't produce a gas.
It's at 50, it's at 20% efficiency, not at 100% efficiency after 10 years. What could be the reason based on your, you could pick out 2 reasons for me based on your.
Yeah, you have to look for fat acids, you have to look for microelements, you have to look for, if a plant is not running, I believe nothing. I'm to tell you the truth, because you will never get the truth from the operator, because he only doesn't know 90% of it. So you have to make sure that all the values are really good. Let's say you have press mud. Oh, the press mud is fresh. Believe me, it's not fresh. It's from a storage outside. It's molded. It's already stored for years.
Yes.
You don't know. Better you have a on site. Take a look. check all the parameters, look what the people are doing over the day. We have, if you have a satellite, if we have on Google Maps, whatever you use in India, if you have a top view on site, you can see where they truck it, where they drive every day, and then you can make up your mind and look what's going wrong. Because if it's easy, if substrate is okay and you heat it, you will gain gas. So you can't avoid. So somebody is doing something wrong.
In the substrate.
Could be in substrate, could be micro elements, could be mismanagement in temperature.
Okay. I
So
think
you can. It's not difficult, but you can do plenty of mistakes. So you need some experience with it.
I guess that also comes from the fact that you can't control at least 50% of what's happening.
My guess is it's more difficult in India because you have more employees. So let's say in Germany, a well-equipped biogas plant could be operate from 1 or 1.5 people. In India, you have 10.
Thank you.
I will ask the question what Akram sir wanted to know. So he wanted to know about the biogas production from maize silage and all, which was shown in the plant. So Rückert sir, can you please explain a bit on that?
So one thing before Rückert answers, so if you see the analysis in the PowerPoint, so there's a 6 TPD generated in less than 4,000 meter cube digester. So definitely it's a very high gas. So Rückert, can you just explain us why there's so much gas coming up compared to regular substrates in maize in this plant?
So maize is a high energy plant, very less lignin, not that much fibers. It's not, it's 2 to 3 meters high. And we have corn as well. It's not only, let's say, grass, or it has lots of parts of corn, because if you let it grow, it dries, and then you can have grain, maize grain, or maize corn. And that's why we have more energy in this plant instead of Napier grass, is my guess. So half of the energy is taken from the corn.
Yeah, good evening, Mr. Rückert and other colleagues.
Mario
Namaskar. Namaskar. Yeah. Have few questions on silage. You mean you're talking about the maize? It including the seed, or it's only the stuff after removing the seed?
So both could be done. If the corn is taken, you can use the rest of the plant as well. But in Europe, almost it takes a whole plant.
Whole plant?
Yes.
Yeah, okay. It look like a powder. You make silage, you cut this one maize and make powder, right?
That's not like really powder. So it's small pieces, but not powder. There's no need to do it that small. Let's say 1, 2, 3 centimeters is okay.
What about the economics? Because Indian condition, our people, they take out the seed. Rest will be there. We can collect it at a cheaper rate. But if you include the seed, this will be an expensive one. As per your presentation, use for 35% of maize silage and 65% Napier grass. Is it right, or?
No, we don't have Napier grass.
Napier grass, no.
It's another kind of grass. It's not that high, but it's grass as well.
Can we use both as a feedstock, silage of corn and super Napier silage? Can we use together?
Sure. Yeah. The more different substrate you have, the better it is. It's like in a menu. If you only have rice, you can't live for long. You need vegetables, you need oil and all stuff. So it's better to mix. And it's easier to operate.
Yeah. By presentation, I understood this silage you collect only once and use it for the whole year.
Right.
But at the other end, super napier will be collected. Yeah, fresh it can be collected. These two together can be used, or is it any issue with bacteria or anything? Any issues
Yeah,
may come.
you have to
One
make
is
sure
dry. One is
you have to
dry.
make
Another
sure
one is wet. Yeah.
you have to make sure that you don't change menu too quick. If you change menu from silo to fresh Napier grass, you give some weeks to mix it, to start with fresh Napier grass and more. Give several weeks in between and the bacteria will adopt.
Fine. Thank you. And one more question I have. So what's the heat? How is heat is generated? You are saying it's 47 degrees to be maintained inside the digester. So for that, I believe we need to insulate the tank as well to retain the heat.
Right.
So how the heat is generated? Like this is steam or electricity, or how is what's the media?
Yeah, you can use lost steam. You can blow in steam if you have. So for sugar mill, it would be perfect because steam is available. If you don't have steam, you can use the external heat exchanger, heat it with steam or whatever, with hot water.
There is another question. As you said, I echo with your opinion. So the one who operates very critical and knowledgeable, and getting a skilled operator is not easy these days, and we need to pay. And how much manpower is required? Say, for example, say to run a 5 or 6 TPD plant. How much manpower is required? How they should be scheduled? Like 24-hour or 8 into 3 or 12 into 2? How they should be scheduled?
It really depends on equipment. On the PLC, is a plant well equipped with sensor systems or not? That is hard to say.
Is there any specific qualification we have to consider, like previous experience or a fresh you can take, someone who work in gas plant or something like this?
If I have the choice, I would take a farmer. He's skilled in animals like chicken, poultries, so for layers of meat production. These people will really understand what the bacteria need, and they are working in time. If ventilation is off, they know that they need to start it. They have to react if something happens on site. So this is okay. And they are connected. They can see it if the food is not good. It's problems with the food, with the smell. They know how it needs to smell, or if you find someone like that.
Thank you. And one last question. Is it which one is for constructing a digester? Which one is good, concrete or the MS?
So it's only a question of price. Bacteria. My saying is bacteria don't mind. They will not realize if you keep them warm.
Okay. Thank you, Rückert. Thank you. Thank you for your answers.
Thank you, Mr. Vrindavanam. Thank you. Okay, so that brings us to the end of our session today. For those of you whose questions we have not been able to answer, I would like to share that we will definitely be taking another session, another similar session like this very soon. We'll keep you posted about that. And Rückert, a special thank you to you for being so patient, for so patiently responding to all of those questions. And to everyone else, thank you so much for being here. Please follow EcoYou's Energy LinkedIn page. We do update it quite often, and please be in touch with our team.
So then from my side, thank you very much for inviting me. Rashi, for you, for the very experienced guidance through this job, even if you're not biogas expert, and for Himanshi on site. She was been running around the plant very quick. So thank you everybody for very professional meeting. And
thank you all,
hopeful-
and we hope to be in touch, and we hope to have much more engaging conversations like this in this splendidly growing industry.
Thank you.
Okay.